You know that chart that's in pretty much every single science classroom? Well, what if I told you it's actually a detective story? It's a map that unlocked the fundamental code of our entire universe. Today, we're going to crack the case of the periodic table, a story about chaos, a brilliant detective, and a hidden pattern that changed everything.
So this was the big question, right? It's the one that haunted chemists for decades. I mean, they discovered dozens of the universe's most basic building blocks, but they had absolutely no idea how they all fit together. It was just a world of pure chemical chaos, and they were desperate to find a single, elegant pattern to make sense of it all.
Okay, let's set the scene. We're going back to the mid-19th century. Chemistry, well, it was kind of the Wild West. Discoveries were happening left and right, but the whole field was stuck in a state of total confusion, all because of one huge, frustrating problem.
By 1860, scientists had identified over 60 unique elements. Now imagine trying to learn a language that has 60 letters, but no alphabet to organize them. That's what they were dealing with. It was an absolute nightmare of information overload.
But you know, the real problem was actually even deeper than that. Nobody could agree on how to measure the weight of an atom. Seriously. Different labs were getting different results for the very same element. It was like trying to build a house where every single builder was using their own custom ruler. Progress was pretty much impossible.
And then, finally, a breakthrough. The world's top chemists all gathered in Karlsruhe, Germany, and they were determined to sort out this mess once and for all. This one meeting would end up changing everything.
An Italian chemist, Stanislao Cannizzaro, he stood up and presented this brilliantly logical method for calculating atomic mass. And suddenly, for the first time, everyone in the room could agree on the numbers. The universal ruler had been found. And with this new tool, the real detective work could finally begin.
All right, so enter our hero, Dmitry Mendeleev, a truly brilliant Russian chemist. Now that chemist had standardized atomic masses, he took on the massive challenge of taming that elemental chaos.
And what's so fascinating here is that his motivation wasn't some grand quest to unlock the secrets of the universe. Nope, he had a much more practical problem. He was writing a textbook, and he just needed a logical way to explain all these different elements to his students. So what'd he do? He basically invented a game. He created a set of cards, kind of like a deck of playing cards. Each card had one element's name, its brand new atomic mass, and all of its known chemical properties. And then he just started playing, let's call it chemical solitaire. He was arranging and rearranging these cards for hours, just searching for some kind of hidden logic. And then, as he was laying out these cards in order of increasing atomic mass, something pretty incredible happened. A hidden rhythm, this repeating pattern, just started to emerge from all that chaos. He discovered that the properties of the elements, they repeated themselves in this predictable, regular pattern. This is what we call periodicity. Think of the days of the week, or the seasons of the year. They repeat in a cycle. Mendeleev realized the elements did the exact same thing. And here it is, his very first published table from 1869. You can see how he started grouping elements with similar properties into these vertical columns. But the real genius here, it isn't just in what he organized. It's in the blank spaces that he intentionally left behind.
This is where you see just how brilliant he was. He trusted the pattern of the properties more than his own primary rule of increasing atomic mass. For instance, he saw that tellurium, even though it was a little heavier, behaved just like the elements in a certain column. So he boldly swapped it with iodine, breaking his own rule just to preserve that deeper logic. And his intuition? It was spot on.
And that brings us back to those gaps in the grid. This is what separated Mendeleev from every other scientist trying to solve this puzzle. You see those empty spaces, they weren't mistakes. Oh no, they were predictions.
I mean, think about it. It's one thing to organize all the information you already have, but it's something else entirely to predict new information with confidence. Mendeleev basically told the entire scientific world, hey, there are elements we haven't found yet, and when you do find them, here's exactly what they'll be like.
And he didn't just say, an element is missing here. No, he described it in amazing detail. He predicted an element he called eka-silicon, and, well, just look at the slide. He predicted its atomic mass and even its density with unbelievable accuracy. When germanium was finally discovered 15 years later, the match was just breathtaking.
And he did this not just once, but for 3 separate elements. By 1886, scandium, gallium, and germanium had all been discovered, right where he said they'd be. This was the ultimate proof.
It cemented his legacy. His table wasn't just some clever chart. It was a predictive map to the very code of matter. So, Mendeleev's incredible work laid the foundation for what we now call the periodic law, a true principle of the universe. But believe it or not, the story didn't end there.
This timeline really shows how science builds on itself. First, Cannizzaro gave everyone the right tools. Then Mendeleev found the pattern using atomic mass. But the final critical piece of the puzzle arrived in 1913. A physicist named Henry Moseley figured out that the true organizing principle wasn't mass at all, but atomic number, the number of protons in an atom's core. And by reordering the table that way, those last few little inconsistencies, like that tellurium-iodine swap, they vanished completely.
And that discovery led us to the modern periodic law. It's that elegant rule Mendeleev was searching for all along. The properties of the elements are a direct, periodic function of their atomic number. It's simple, it's powerful, and it is totally universal. And when we say universal, we really mean it. The very elements organized so neatly on our table were forged in the heart of stellar explosions, like the supernova that created this incredible nebula. The order that Mendeleev found in a Russian lab applies to the farthest reaches of the cosmos.
You know, Mendeleev's true legacy is that he taught us to search for the profound patterns that are hidden inside of nature's chaos. His table became the very first Rosetta Stone for chemistry, letting us translate the fundamental language of the universe. And it just makes you wonder, doesn't it? What other cosmic codes are still out there, just waiting for the next detective to come along and crack them?